Hey everybody, welcome to our third flipped video lesson on inequalities here. We've done individual single variable inequalities, we've done compound inequalities, and now we're going to start talking about what happens when we throw absolute value bars into the mix. Well, before we start talking about absolute value bars and inequalities, let's review what we talked about them with equations, because a lot of it is going to be very similar. So we said if we have an absolute value equation such as the absolute value of x is equal to 6, what this is telling us is that x is 6 units away from 0. Well, so our solutions have to be numbers that are 6 units away from 0, and there's two. X could be at -6 and be 6 units away from 0, or it could be at +6 and be at 6 units away from 0. So we know there are exactly two solutions because there are exactly two values, exactly a distance of 6 away from 0. And we use this concept to create two equations every time we solved our absolute value equations to find a solution for each of those possible directions. And again, sorry guys that this pops up every time, but I don't know how to make it stop. So we have two solutions to account for both of those possible ways our equation could be true, going to the left and going to the right. So we're going to take that concept now, but we're going to change the equal sign to an inequality sign. And now how does that change what we're working with here? Well, let's take a look here. So we've got the absolute value of x, same as before, but now it's greater than 6. So now we're not looking for something that is 6 units away from 0. We're looking for x to be greater than 6 units away from 0. And what that's really telling us, if we think about that in a number line, what that's saying is we have to take numbers that are to the left of -6, right? Because the -6 is 6 units away. We want greater than that. Or to the right of +6. So you can see the inequality that creates for us. X is less than -6 or x is greater than 6. We can see that graph represented here. And we can see these both intervals of our graph here. Notice that this creates an infinite number of solutions. Not all real numbers, because there are numbers in between -6 and 6 that we are not including. But it is an infinite number of solutions. And here's an important thing. Notice that these distances, these intervals, are going away from each other. And that's going to be kind of a phrase and terminology we're using when we're talking about an inequality being greater than a value, being greater than a certain distance away from 0. Also notice this graph looks very familiar, or should look familiar from our previous video lesson, and this is the graph of a union solution set. Which is why I put the word or in between x is less than -6 and x is greater than 6. This is going to be true whenever we have a greater than symbol and the distances are moving away from each other, becoming greater away from 0. And that may not make a whole much sense, but the distance away from 0 is greater than a specific value, moving away from 0 and away from each other. So what happens if we flip the inequality sign around? Now we have the absolute value of x is less than or equal to 6. Well, we know the equal part changes the open circle to a closed circle, right? But what about the less than part? How does that change? Well, now we're saying x is less than or equal to 6 units away from 0. So again, if we think about what that's saying is, that means if we start at -6 and include -6 now, we have to go closer to 0, less than that distance away from 0. So we have to go to the right of -6, and we have to again then go closer to 0. We have to go to the left of +6. So these now distances are moving towards each other. And you might say, well, why don't they then just keep going for the whole number line? Well, again, they have to be closer to 0, less than 6 units away. So as soon as they cross over each other and hit the other number, they have to stop, because going all the way to -7 or going to +7 would make this inequality untrue. That would be more than 6 units away from 0. And what we should notice again is that there are an infinite number of solutions. You might be wondering about that because this graph is not going to positive or negative infinity like the graph above, but there are an infinite number of decimals in between each integer on the number line, 1.1, 1.01, 1.001, and so forth, right? And so I still have an infinite number of solutions, but here's the key. The distances are an infinite number of values. The distances are moving towards each other. And this creates an intersection, right? Our solutions here, our numbers that will make this inequality true, are the numbers that are in between -6 and 6, and they would make both of these inequalities true here. So we use the word and because that is what we're looking for when we deal with an inequality sign that is less than or equal to, and the distances are moving towards each other. Well, this is kind of the big idea here with our inequality. So if this is blowing your mind, if you're like, you know, please come to class and we'll talk about this some more and work on this. We're going to take an extra day, but we don't know you don't understand if you don't ask questions. So now let's take what we know and actually start solving, right? Because before we were really just representing our solutions there. So the only difference between this inequality and the previous ones is now instead of just having x inside the inequality, we have an expression of x plus 5. So this is saying the same thing. This is x plus 5 is 11 or more units away from 0, right? So that means x plus 5 can start at -11, but it's got to go more than 11 units away from 0, so that has to go to the left. And it has to start at +11, but again, it has to go away from 0 to the right. Notice those distances with greater than are going away from each other. This demonstrates a union. So when I represent each of these as an inequality, I'm going to have x plus 5 is less than or equal to -11, right, to the left of -11, or x plus 5 is greater than or equal to +11. And this gives me two inequalities, the same way we had two equations with our absolute value equations. We're always going to have two inequalities with our absolute value inequalities. Then I can solve and get x is less than or equal to -16, or x is greater than or equal to 6, and then I can graph the solutions. So what this is finally saying is any number that is smaller than -16 or larger than 6, including -16 and 6, will make the original inequality, the one we started up way at the top with the absolute value bars, true. Those are the numbers that will make our inequality true. Those are our solutions. And we needed to create those two inequalities to get that. Okay, so let's now flip the inequality sign. The absolute value of 6x minus 3 is less than 15. So again, that's what that's saying is it's less than 15 units away, which means our distances are moving closer to 0. It's going to be in between -15 and +15. Those are going to be boundaries, right? So it's going to look like this. Our distances that could allow us to create our inequalities are moving towards each other and crossing over each other in between 15 and -15. This demonstrates an intersection, so I put the word and in between 6x minus 3, and we can see that it's got to be greater than to the right of -15, and it's got to be less than to the left of +15. So I solve each of these, I can graph the solutions, and what we see is any number in between -2 and 3, again, will make the original inequality, the one with the absolute value bars back at the top, true. Well, one more thing to talk about here before we turn you loose on your own is what happens if the inequality, the absolute value expression, is not alone. Well, we've talked about this. Before we can start creating equations or inequalities, we have to get it alone. So I'm going to subtract 6 from each side to get rid of that constant, and then I have the absolute value of x plus 2 is greater than or equal to 7. What that's telling me is x plus 2 is more than 7 units away from 0, so my distances are moving away from each other. So that is less than -7 to the left of -7 and greater than +7 to the right of +7. And since we know that that's a union situation because it's a greater than symbol, we're going to be dealing with an or, right? So x is less than or equal to 9 or x is greater than or equal to 5. We can graph the solutions, and any number to the smaller than -9 or bigger than 5, including -9 and 5, will make the original inequality that we started with way back up at the top true. Well, we've done a number of these on our own, together here, so now we're going to turn you loose to try these on your own. So pause the video, write your two inequalities, think about whether it's an intersection or a union to use the correct word and or, solve the inequalities, and then graph the solutions. That makes sense? Solve the inequalities, graph the solutions. Ready, go. Well, let's see how you did. Hopefully you came up with these solutions. If you need to pause the video to check your work, go ahead and do that. But please, 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 if you have questions, if you're not getting this stuff, guys, please come to class with questions. We'll be happy to talk, and we'll practice some problems together. We'll answer your questions, but you've got to make sure you're asking them. And that brings us to the end, and thank you. So keep calm, Grayslake Central Algebra students, and inequality on.